This is our second video in our calculus course, and in this video we will discuss the domain of definition of a function. In the previous video, you said that a function is a mapping or a relation between two sets. The first set is the input set, let's now call it A, to another set that is called the output set, and let's call it now B. A contains the pre-image elements of the function, and they are oftenly called X, and they are the pre-images of the function, while B contains the image of the function, and they are oftenly called Y. By this representation, now we can annotate f in the following. F is the function or the mapping from A to B, from the input set to the output set, and it takes x, the input values, and returns y, such that we've seen that y can be any relation that involves or doesn't involve x, such as y equals to x, y equals to x squared, y equals to constant, and whatever. Now let's discuss more about A and B. We've seen that A is called the domain of definition of the function, while B is called the range of the function. What is meant by the domain of definition of the function? The domain of definition of the function is the set of all pre-images of a function f, so that the domain contains all the input values that actually have an output by this function, while the range is the set of all images by f. So the range is the set of all output values given by f. We've seen that a function can be even represented as a numerical equation, or it can be also represented as a graphical graph using the coordinate system. Let's now analyze the domain and the range of some graphs. Let's start by the light blue graph. In order to determine the domain of definition of a function, we have to project the function on the x-axis, and the interval that, or the set of numbers that are seen or that are covered by this projection, is called the domain of definition of the function, because we've said that x contains the input or the pre-image values of a function. Why? In order to find the range of this function or any function, we have to project the function or the graphical representation on the y-axis, and the interval will be the range of this function, because we've said that y contains the image or the output variables of any function. So let's now project the light blue function on the x-axis. So we will start by its starting point, that is 0, and it stops on the point 6. The projection of the light blue graph on the x-axis is the interval of 0 to 6, where 0 and 6 are both contained in the interval. So the domain of definition of the light blue function is 0 to 6, where 6 is contained and 0 is also contained. Let's now find the range of this function. So we will find, or we have to find, the lowest point of this function and its highest point. So we can see that the lowest point of this function is on the point having the elevation of -1, and the highest point of this function is the point having the elevation of 2. The interval between -1 to 2 actually represents the projection of this function on the y-axis. So this interval actually represents the range of the light blue function. So the range of the light blue function is -1 to 2, where 2 is contained and -1 is contained. Let's now find the domain of definition and the range of the red graph. The red graph is starting from -3, where -3 is not contained because it has this representation, and it ends on +5. So in order to find the domain of this graph, we have to project it on the x-axis. We can see that the projection of the red graph is on the x-axis is from -3 to +5. So the domain of definition of the red graph is from -3 to +5, where +5 is contained, but -3 is not contained, as we've said. Now, the range of the red graph is the interval from its lowest point, that is -2, to the highest point, that is +6. So the interval that is actually the projection of the red graph on the y-axis is the range of the red graph, that is from -2 to +6, where 6 is contained, but -2 is not contained in the range. Now let's find the last domain and range for the green graph. As we made in the light blue and the red graph, now let's make the same. Let's now project the green graph on the x-axis. We can see that the projection of the green graph on the x-axis leads us to the interval of -6 to +7, that is leading us to know the domain of definition of the green graph. So the green graph starts from -6 and ends on +7, where +7 is contained in the graph, while -6 is not contained in the graph because of this representation. Now let's find the range of the green graph. In order to find the range of the green graph, we have to find the lowest point of this graph, and the lowest point of this graph is seen to be -4, where the highest point of this graph is +4. So the interval between -4 and +4 is actually representing the projection of the green graph on the y-axis. This leads us to know the range of the green graph. So the range of the green graph is between -4 and 4, where 4 is contained in the interval, and -4 is also contained in this graph. After we've seen how to determine the domain and the range of some functions by using their graphical representations, it's time to try to figure out the domain and the range for some functions using their numerical equation. In order to determine the domain and the range of a function using the numerical equation, we have to interpret it and make some analysis, or we have to graph it and make the same procedure we've made in the determination of the domain and the range in the graphical representation. So let's take the first example of y equals to cosine x. In order to determine the domain and the range of cosine x or even sine of x, we have to make some analysis. We know from different classes that cosine x and sine of x in trigonometry lies between -1 and +1 on the y-axis, where they can accept whatever number in their function. So x can be any real number, but the result of cosine x and sine x always is between -1 and +1. So x can be any number, Then any number can be the input of this function, that is y equals to cosine x or y equals to sine of x. Then the pre-image or the domain set of this function is to be the whole R real numbers, that is equal to the interval from -infinity to +infinity. We've also said that we know that cosine x and sine of x both lies between -1 and +1. This leads us to know that the range of cosine of x and sine of x is equal to -1 to +1, both are included. Let's now take these two examples of numerical functions in order to determine their domain and their range. Let's now start by the function of y equals radical of x. We know from elementary school that the number under the radical or the square root must be greater than or equal than 0. Then x in this case must be equal or greater than 0. This makes us exclude the numbers that are negative from the input set. This leads to know that the pre-image element set or the domain of definition of this function will start from 0 and continue to plus infinity. Then the domain will be from 0 included to plus infinity. Let's now try to figure out what is the range of this function. To know the range of this function, we must know the lowest point that this function may have and its highest point. We know that every number that is square rooted will stay positive whatever the number is. So the lowest value of y can be equals to 0 when x equals to 0. Then the range will start from 0. The highest point of the range will tend and approach to plus infinity as x is approaching to plus infinity, because whenever the x is increasing, y equals radical of x will always increase until reaching a very high number approaching plus infinity. Then the range will be from 0 included to plus infinity. For the function y equals 1 over x, we've known from the elementary school also that the denominator of any fraction must be not equal to 0. Then, in this case, x could be any number different than 0. This makes us reach the idea that the domain of definition of this function is any number that is different from 0, then it's from minus infinity to 0 excluded, union 0 excluded to plus infinity. This representation means that the domain can be any number different than 0, and it is also represented as the set R, real number, with a star on it, meaning that 0 is excluded. Let's now try to figure out the range of this function. This function actually is the inverse proportional function of two variables, where y equals 1 over x. Whenever x is increasing, y will be decreasing, and whenever x is decreasing, y will be increasing. Then let's take the example of x being 1000, for example. Y will be 1 over 1000 will be equal to 0.001. For x being minus 1000, y will be equals to minus 0.01. For x equals to 0.001, y will be equal to 1000, and for x being minus 0.001, y equals to minus 1000. Those examples makes us know the idea that whenever x is increasing and reaching minus infinity or plus infinity, y will be decreasing and will be tending to reach 0. In the opposite, when x is tending to 0 from the negative side or the positive side, y will be increasing to the minus infinity or plus infinity. Then the range of this function actually is from minus infinity to plus infinity, because this function actually is ranged from minus infinity to plus infinity, excluding 0, because there is no number for x that makes y equals to 0. Then the function range is from minus infinity to 0, excluding 0 to plus infinity. For graphical representations for a function, the domain is the interval from the starting point to the ending point on the x-axis projection of the graph. We have to say that it is also including the graph. In the opposite, the range of a function is the interval from the lowest point to the highest point on the graph that also includes the graph. What does the idea of including the graph means? Let's take the example of this graph or this graphical representation for a function. We can see that this graphical representation of a function is not continuous. So if we project the graph on the x-axis and the y-axis, we will have the following. We will have this projection on the x-axis and this projection on the y-axis. This leads us to determine that the domain of definition of this function is this part or this interval added to this interval, while the range of this function is this interval added to this interval. So the idea of the range and the domain of a function is the interval from the starting point or the lowest point to the final point or the highest point is not so precise in all cases, because in some cases we can have gaps between the parts of a function or parts of the graphical representation of a function. Now let's go for the numerical representation of a function. In a numerical representation for a function, the domain and the range of a function is interpreted, and it is not easy as in the graphical representations. So let's now take some notes that makes the interpretation of the domain and the range in a numerical representation more simple. The domain of definition of any polynomial in the form of ax to the power n plus bx to the power n minus 1 till x to the power 0 is the whole real number set R that is defined from minus infinity to plus infinity. What does that mean? Take the function of y equals to x to the power 4, for example, plus 5x to the power 3 plus 2x plus 1. We can see that this function is in the form of a polynomial. So directly we can conclude that the domain of definition of this function is the whole set R, or the domain of definition is from minus infinity to plus infinity. And this is actually logical because we can see that we can substitute x by any real number from minus infinity to plus infinity. Now take the domain of any function to be the whole real number set R, and then check the problems in the function and delete the problem from the domain. What does that mean? This sentence makes us complete the map of finding the domain of a function by the numerical representation of it in our brains. How is that possible? Take the example of y equals to radical of x over 1 minus x. In our brain, we should start by defining the domain of definition from minus infinity to plus infinity. So we start by this concept and look for the problems in the function. The problem in the function is, first of all, that we have a radical of x, then x, as we've seen, must be greater or equal than 0. This is the first condition. And the second condition is that y minus x should not be equals to 0, then x should not be equal to 1. So we started by that the domain of definition is from minus infinity to plus infinity. Then we've seen that x should be greater than or equal than 0. Then we delete the negative part from the domain of definition. Thus, we will lead to the domain of definition of from 0 to plus infinity. But we can see that x also should be not equal to 1. Then the domain of definition is therefore the positive part of the domain of definition, excluding the number 1. Then the domain of definition will be 0 included to 1 excluded, union 1 excluded to plus infinity. This is a general map to find any domain of definition for any numerical representation for a function. Oftenly, the problems in a function can be radical of x or a fraction that the denominator of it must not be equal to 0, or ln of x, and we will see ln of x in the upcoming sessions. Finally, finding the range of a function from its numerical representation is oftenly complex for more complex functions and cannot be done by simple calculus. So don't panic and have a good day.